So far, we have discussed the working of for loop, while loop and do while loop. In this lecture, we are going to learn how we can actually solve a problem using the counter-controlled loop. Now, what do you think is a counter-controlled loop? Whenever you are actually repeating something by counting, that is the counter-controlled loop. The loop is controlled by the counter value. So, whenever you are having a problem at hand, we do not directly go and start writing your code. Coding is the last thing that you do. Okay, before you do coding, you have to invest much of your time in the design. Okay, so you have to yourself be clear first using pen and paper how you can actually solve that problem. Then you have to design your solution. Only then you go for coding. So I have actually given you this 7-step procedure which you can actually follow to solve any problem using the counter controlled loop. Now let's try to execute these 7 steps on a problem of displaying the multiplication table of 12 up to 10 times. So step number 1 is to read and understand the problem statement. It's very important for you to read and understand what does a problem demand. Okay, so this is step number 1, very important step. If you do not understand the problem statement, read it one more time and then understand what it actually demands. So in this problem, you are supposed to display the multiplication table of the number 12 up to how many times? Up to 10 times. Problem statement is pretty clear, right? So step 1 is done. Now step 2 is you have to solve this problem yourself, first of all using pen and paper. Very important thing. Okay, so first of all you have to yourself write down, you should be able to write down the multiplication table of 12 up to 10 times. You should know how it actually works, because before you actually code, you should know yourself how it actually works. So this is the multiplication table of 12. It's written down here up to 10 times. So 12 times 1 is 12. 12 times 2 is 24. This is the table kind of a thing. It's a multiplication table of 12 up to 10 times. So 12 times 10 is 120. So this is also pretty clear, right? We all are aware how to write the multiplication table. Okay. So step number 2 is done. Now step number 3 is, do you see any pattern repeating in this table? Do you see, is there something repeating in this table? If you just look at this, each line of this multiplication table, it is 12, right, times something equals to something. Every line, see, 12 times 1, first line is 12 times 1 equals to 12. In the second line, it's 12 times 2 equals to 24. In the last line, it is 12 times 10 equals to 120, right? So I can somehow say that it is 12 times, let's say something is I, okay, something I is actually changing. I is initially 1, and then it is 2, and then it is 3, and then finally I is 10. Because I is changing, therefore the product is also changing. And here it's the product of 12 and I, so it is 12 times I. Okay, because 12 times 1 is 12, 12 times 2 is 24, so this is 12 times I. Okay, so this is something that is being repeated, right? So I see this pattern is repeated in this table. So do you see any pattern repeating? Yes. Okay, now what is the statement that is being repeated? It's very simple. It is 12 times I is equals to 12 into I. So this is the statement that is being repeated. Now step number 5 is, how many times is this statement being repeated? How many times is this statement being repeated? 12 times 1 is 12, 12 times 2 is 24, similarly it goes up to 12 times 10 is 120. So can I say that this is being repeated for, starting for I equals to 1 to 10, so it is repeating for 10 times, isn't it? Because I am finding the multiplication table of 12 starting from 1 time to 10 times. Okay, so it is repeating for 10 times. Now these many steps are done. Now let's go with step number 6. In step number 6, you need to identify the following to be included in the for loop. Now we are going to, because this is a counter control loop. Why this is a counter control loop? Because we already know beforehand that this loop should run for 10 times. So it's very easy for us to write a for loop for this. So I can write a syntax for loop here, for, okay, open the brackets like this. This is the parenthesis. Okay, now here I need to write initialization, condition and the updation statement. So first is the, what is the initialization statement? What is the initial value, right? So initially the first value of I here is 1. Initially the value of I is 1, right? I is changing from 1 to 10. So initially I is 1. So I'm assuming that there's a variable already created called as I, okay, which is my counter variable. So initially I is 1, right? And so this is the initialization statement, I is 1. Now what is the loop controlling condition? What controls the loop? I is ranging from 1 to 10, right? So the last value of I is 10. So the value of I cannot be greater than 10, right? So I must be always less than equals to 10. This is the loop control condition. So I'll write I is less than equals to 10 here, loop control condition. And then what is the updation statement? Each time I'm updating I by 1. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. So I is, starting from 1 and going up to 10, each time updated by 1. So I can write I plus plus. So I plus plus is my updation statement. So this will make sure that, this loop will run for 10 times. Now, what will come in the body? What is the statement that is to be repeated, right? So the statement that is to be repeated is this one, okay? 12 times I equals to 12 times I, okay? So how do I write this? I'll just write printf, okay? Printf. So it is something, that is percentage d, something times, so this is just a cross symbol, something else equals to the answer. All of these are integer values, so I'll write percentage d and I provide comma. After this I'll write what does first percentage d corresponds to. The first percentage d corresponds to 12, right? The first percentage d corresponds to 12, so I can directly write it here as 12, okay, comma. What does second percentage d corresponds to? The second percentage d corresponds to I. I is changing from 1 to 10, okay, this is I, 1 to 10. And what does third percentage d corresponds to? It is the product of 12 and I, so I'll write 12 times, this is the multiplication symbol, asterisk I, okay, and then you close it. So this percentage d corresponds to 12, this percentage d corresponds to I, and this percentage d corresponds to 12 times I, okay. So if you just follow these particular steps, you should be able to generate the for loop like this, okay. And finally now we are going to write this as a code and then see how it really works. So I've already created this program called as multiplication table.c, wherein I need to display the multiplication table of 12 up to 10 times. So for that I'll be using a counter variable. So let's say the counter variable is I. Now I have to write the for loop. For initialization, the first value of I is 1, right? The value of I should always be less than equals to 10, and each time the value of I is updated by 1. So this is the for loop, okay. So what is to be repeated will go in the body like this. So printf, I'll write something percentage d times, so this is just x, okay, percentage d equals to percentage d. I'll give a new line because I would like to display each multiplication in a new line. And then first percentage d corresponds to 12, second percentage d corresponds to I, and third percentage d corresponds to the product of 12 and I, okay. So if I just write this, I think this would work fine. Let's try to compile this, and you see this is the multiplication table of 12 up to 10 times. Isn't it very interesting, right? Now I can also change this code. If I have to display the multiplication table of 12 up to 15 times, what do? It's very simple. I just need to change this 10 to 15 because I need to go up to 15 times, okay. So let's try to compile this code and then run it one more time. Now you see the multiplication table of 12 is displayed up to 15 times in a click of a button, right? So that's very interesting. Now you did not remember the multiplication table of any number. So now if I ask you to find out the multiplication table of 16, what do? Where do you make your changes? Is very simple. You just change this 12. I need to change this 12. I'll make it as 16, okay. Now you just compile this one more time, run this. Now you see this is the multiplication table of 16. Now here if you observe it closely, the output is not correct. 16 times 1 is 12. It should be 16, right? This is because I did not change the third argument here. This is still 12 times I. I need to convert this to 16 times I. Save this and then compile this again and then run it. Now you will see 16 times 1 is 16, 16 times 2 is 32, and it works fine. Okay, now let's make this program a little bit more useful by actually letting user find the multiplication of any number he or she wants to. Okay, so for that, let's say the number is n, so I'll ask the user to enter your number of choice. Okay, now let's scan that number, %d %n. So I'm trying to find the multiplication table of n and not 16. So wherever I have 16, I need to replace that by n. Okay, whenever there is 16, I need to replace that by n. Okay, that's all. And now let's see what happens. So let's compile this. Let's say I would like to find the multiplication table of 22, and now it works fine. 22 times 1 is 22, 22 times 2 is 44, and it works really great. Okay, now we can improve this program. This is displaying the multiplication table up to 15 times. I want user to enter this number as well. Okay, let this number be a variable. Okay, so I'll ask the user printf enter the limit. Okay, so what is the limit? So I'll have to scan that number, %d. Let's say the variable is limit. Okay, so I'll have to create this variable here as limit. Okay, now the limit will come here instead of 15. This will be limit. Okay, so now let's try to compile this code and then run this. So enter your number of choice. Let me find the multiplication table of 34 up to how many times? What is the limit? Let's say the limit is 10. So it is 34 times 1 up to 34 times 10. Now I can do the same thing. Enter the number of your choice. Let's say 46. I'm finding the multiplication table of 46 up to how many times? Let's say up to 23 times. So it is 46 times 1, 46 times 2, and the answer is correct. Up to, it goes up to 46 times 23, that is 1058. Okay, isn't this really interesting, right? So this is the power you get once you learn looping. So the objective of this lecture was to help you design your own counter control loop by using pen and paper, and then write a code to implement the same. I hope you are clear on this.